This screencast is Chapter 4, Part 2, where we are going to look at negative and zero exponents. So we are going to skip down to number 29, and we're going to look at this table, and I filled out the rest, and we're going to look for a pattern in his list, and how are the values to the right of the equal sign changing. So as we are going, starting here at 2 to the 5th power to get 32, 2 to the 4th is 16, 2 cubed is 8, 2 squared is 4, 2 to the 1 power is 2, 2 to the 0 power is 1, and then we start getting these negative exponents, and you can see what's happening to the number. So as we are going down the list, our numbers are getting smaller. And the values, when we are getting negative exponents, our numbers are going to become fractions. So I'm going to make a note that the numbers are getting smaller. And our negative exponent is going to give us a fraction. So we're going to take a look at number 30, and we have x to the m power over x to the m. And what we're going to do is we're going to simplify this. So I'm going to, for example, say that m is going to equal 3. So this would become x to the third over x to the third. So we talked in the previous part that if we, write it all out, so we have 3 x's on the top, 3 on the bottom, we can form those giant ones and simplify. All of our x's are going to simplify to just be 1. Anytime we have the same thing in the numerator and the denominator, it's going to reduce to 1. So another example, if we think of like whole numbers, say we have 2 divided by 2. Well, that's going to simplify to 1. So for this example, x to the m, we don't know what that is. It could be any number. So it's going to be x times x times x times, x. We don't know. This could go on forever. Same thing in the bottom. So it's going to simplify to 1. So no matter how many x's we have in the numerator and denominator, since they're the same number, it's all going to simplify to 1. As you can see, whenever we have a variable or anything that is going to be divided by the same exact thing, it's going to simplify to 1. So another example is, say we have x to the 1,000th power divided by x to the 1,000th power. Since they are identical, you're going to have 1,000 x's in the numerator, 1,000 in the denominator. They're all going to simplify to just be 1. So we're going to start talking about the exponent 0. So anything to the 0 power, so example x to the 0, is always going to equal 1. And to prove this, so if you go back to the example that we have up here, if we take, x cubed divided by x cubed, so if we are to subtract those exponents using those exponent properties, so 3 minus 3 is going to give you 0. So this is the same thing as saying x to the 0 power, which is 1, and x cubed divided by x cubed equals 1. So anytime we have x to the 0 power, or anything to the 0 power, your answer is always going to be 1. Problem 31, we have two guys. They're looking for ways to calculate negative value or negative exponents without extending a pattern. So they're looking at 5 to the negative 2 power, and they simplify differently. Salvador thinks that 5 squared is 25, so 5 to the negative 1 power must be 1 over 25. And Nick thinks that it is 1 over 5 squared. Which student is correct? Well, both of these guys are correct because 1 over 25 is the same thing as 1 over 5 squared. They are equal. So 1 over 5 squared is 1 over 25. So they are both correct. In 32, we're going to take a look at the original expression, and then we're going to break it down. So 6 to the 5th power is going to be 6 times 6 times 6 times 6 times 6. Now 6 to the negative 3rd power, we are going to automatically put that in the denominator because 6 to the negative 3rd power is the same thing as 1 over 6 cubed. So we're going to immediately put those 3 6's in the denominator. We can simplify, and we are now left with 2 6s, which is 6 squared. Part B, we have w to the 5th, so we're going to have 5 w's over 2 w's, because we have this w to the negative 2 power, which is the same thing as 1 over w squared. We can simplify 2 of the w's on the top and the bottom, and left with w cubed. The last example here, we're going to have 5 10s in the numerator and 4 10s in the denominator. And again, it's because 10 to the negative 4th power is the same thing as saying 1 over 10 to the 4th. So 4 of these are going to simplify, and we are left with just 10.